the command line? Also.
Like this?
Yeah.
Okay. Let's see if it works now. Okay, better. So now everything should be fine. Let's go to our Kelly. We can see we have proxy chains, which we will use to route the whole traffic. So what we can do now, for instance, we can do a netcat test to the DC, the domain controller, and see that we can talk through it. So it's just a cool trick to get a SOX connection instead of having to get a Cobalt Strike beacon or a interpreter up and running, bypassing antivirus most of the time. Perhaps you don't even want to run commands locally on the server or computer. Maybe you just want to route the traffic.
And how stealth would you say this is? It's weird that suddenly Windows machine is trying to do SSH connections.
Yeah, I have seen some alerts from a really advanced antivirus, and the thing that it triggered on was that why is SSH connecting to Kerberos on the domain controller? That is a bit weird connection that it makes. Honestly, I don't know how it looks in the normal picture of the client's environment. It depends if they're using SSH, but it is a Windows signed binary. Everything is encrypted and so on. So, of course, if you have approval from the client, then there's no big deal about it. If they discover it, if you're on a red team, it's bad. If it's not a red team, you're just doing a pen test, it should be fine. So I don't know how stealth it is, but it bypasses most of the antivirus unless you start making some weird connections. But it's pretty stable. I really like it. Okay, so I created a folder. So the first thing we will do to get started, we will run the bloodhound to collect all the data from the network. Let me try to zoom in a bit more.
Yeah, please.
So you can see it. Yep. So we will use the proxy chains and Bloodhound Python, I think it's called. It will give you a lot of options. You have to specify your username. So in this case, we are assuming we have a user named Oliver in the domain called Hactrix Live. What is happening? Okay. My password is really simple. This is just our first user. We compromise the user.
Is that your password for Gmail?
Yeah. What is the problem? It's very safe. Special character, big letters, small letters, numbers. Okay. And then the collection method we will use. There are different collection methods. I tend to go with the all, especially in this. You can also, in this setup, you can also go with, like, if you want to be a bit more stealth, you can say, I only want to ask the domain controller some specific flags. But in this case, we will just collect all the information. Now, all is not all. There is a specific one called all except lock on, but it's fine. We'll just collect all. And the domain is hactrix.live. And the DC is DC, the domain controller is dc.hactrix.live. And then we also need to specify the name server. So where should it look up all this? For this Bloodhound Python, you have to specify it for Certify. Certify will try to do a lot of this stuff automatically. But in this case, I know that the domain controller is located on this IP, and then we will save it as a zip. And then it will start running, it will start collecting all the users. And since this is a small environment, it will go really quickly. And it creates this zip file called like a timestamp _ bloodhound. And I try to match that. So if you want to run certify, it has a similar command, certify find. Same again with username, password. And I think that's the only flags you need for certify. As I mentioned, it tries to do a lot of funky stuff. And if it fails, you probably need to specify some more flags, like where's the name server and so on. So this will take small time collecting, and then it prints out a lot of stuff. Now, certify generates 3 types of files by default. It creates a zip file, just like we saw with Bloodhound. And then it also creates a text version and a JSON version. And these are depending on how you want to browse it. Let's take a quick look inside the text version. So it will basically show all the certificate authority we have, which is ca.hactrix.live. It will show all the certificate templates, and we will look a bit closer on that in a bit. But let's start up Bloodhound. Just connect. Now, once you have the zip files, let me find it. Okay, I messed up a bit. But you will get 2 zip files, and it's just drag and drop it into Bloodhound. To speed things up, I already did it before joining the meeting.
Okay.
And this is what you will see when you open up Bloodhound. You will just see which domain admins are here. So just a quick introduction to Bloodhound for those people who don't know it. It has collected all the data. We imported it. And now we can see these graphs, like the administrator is a member of the domain admins group.
Can you make
They have
it a
different
bit bigger? Can you zoom in a little bit? So yeah.
like this,
Yeah, better.
perhaps. Yeah, I know the labels are small. I never
Yeah.
figured out how to make the labels bigger. But this one says member of. I'll try to read them out loud. So we can also find our own user in here, Oliver, and we can right-click and say now we mark it as owned. It will make it a bit easier to navigate and do some queries afterwards. So we have our user, it's owned. We can see all the attributes. This is the data that was collected from the domain controller by Bloodhound. We can see the name, are we an admin, and so on. Some different stuff. We can, for instance, click and see what are our group memberships, what if we unroll all the group memberships, and so on. So really convenient tool. If you never tried it before, I would definitely recommend just playing around with it. So the mainstream Bloodhound version has some different queries. So things we can ask Bloodhound to show us some graphs. And for the fork I made, I also included the certificate templates and the certificate authorities, so the whole Active Directory certificate services. So for instance, we can get a list of all the certificate templates in this environment. And I mentioned earlier, we don't need to know that much about certificates, but the certificate templates themselves are like objects describing how will a certificate be issued, who is allowed to get this certificate, so what permissions, what attributes, a lot of different stuff. We don't need to know all of it. We just need to know how to become a domain admin, of course. So you will see some of them have been marked with a diamond, which shows in Bloodhound that it's a high value, and Certify will do that based on if they are vulnerable to some misconfigurations. And that is because there are some queries that can say, show me a path to a high value target. Okay, so there are some different escalation techniques, and these were described in the white paper by Spectops called Certified Pre-Owned. So they list 8 escalation techniques, and we will go over a handful of them today. Some of them, like ESC6, they all have ESC followed by a number, and it's a different misconfiguration. You can read more about the specific misconfigurations in the white paper. And also I did a ton of blog posts I'll show later on for more resources. But basically, Bloodhound will give us a list of queries we can ask. So we can, for instance, ask, show me all
Sorry, Oliver.
Yep.
There is no way you can zoom into the names of the queries, right?
No, this is, I didn't find a way. I tried before.
Okay, don't worry. Don't worry.
Yeah. Okay, I'll read them out loud. So this one is called Find Misconfigured Certificate Templates, parenthesis ESC01. So if we click on that, it will show us 2 certificate templates. So these are vulnerable to the technique, let's call it, called ESC1. And let's try to check one of them, why it's vulnerable. Well, first of all, it has something called enrollee supply subject. So when a user wants to enroll in this template, they can choose the name, the identification in the final certificate. So it's basically saying, I want this certificate, but I want it with Carlos's name inside it. So maybe it's not bad, but on top of that, it can also be used for client authentication. So I can use this as a proof of identification that I am now Carlos. So this is bad from perspective. Now we also need some other things, such as we should be allowed to enroll in it. And also we prefer that no manager should approve us before enrolling in it. We don't want to ask for it and then wait for a manager to say, yeah, it's okay. So it should be said here, requires manager approval, false. That is good. There's also something called how many approves should you have. That should also be 0.
Okay.
We can also see the certificate authority. We can click on this, see certificate authorities to see who has this one enabled. It might be that it's not enabled by anyone. So there are a big list of certificate templates. If we pull it out here, these are all the certificate templates in Active Directory. But if we click and show only the enabled one, we'll see it's not as much. We can also show the certificate authorities. But in this case, we're interested in the first attack, which is ESC01. And we see 2 templates. We see server and sub-CA. Sub-CA is enabled by default, but only administrators can enroll it. Only administrators can request it. But the server is one I created. And what we can do is we can click on it and we can say, show me who is allowed to enroll in it. We see it's domain computers, domain admins, enterprise admins. Okay, so these are the people or the groups who are allowed to enroll. But as you saw before, we marked our own user as owned. We have compromised it. And there is a query saying, is there any path from my user to this certificate? Can I enroll it by compromising other groups or users? So we will click on that. And it will show us this nice graph. It's a bit messed up. Carlos, you're here too. You're the victim. I'm sorry, you have bad security. No. So this is the graph. Here's our user. It says that we have generic right over Carlos, and we can ask Bloodhound what does it mean? How can we abuse it? This one shows one example of abusing it. It also shows you the OPSEC and so on. I'll show you a different way using certificates, which is, in my opinion, way nicer when certificate services are installed. And then we see Carlos, he has some permissions over Carlos' PC.
Okay.
Yeah.
Very original.
And it's you have something called all extended rights and write account restrictions, and we will see a bit how we can abuse that. Unfortunately, my version and also I believe the mainstream version doesn't have any help for the write account restrictions. So if you click it, it will crash. But we see that Carlos PC is a member of domain computers.
Okay.
And domain computers can find and enroll in server. Okay, so let's start here.
Before you start, there are some questions. What does enrolling means?
Okay, good question. So enrolling in this context means basically, can I request a certificate?
Beklager, det forstod jeg ikke.
Sorry, that's my Google Home. So enrolling means, can I request a certificate based on this template? So these are just templates. It's just settings for the final certificate. And we want the permissions to enroll, which means, can we request a certificate? So that's basically what it means. If we don't have enrollment permissions, we cannot get a certificate based on these settings. And of course, we want the certificate. We want it to be signed by the certificate authority. The certificate authority is trusted by the domain controller for authentication and is trusted by the computers in the environment in general. Yeah, just let me know if there are any questions. Cool. Okay, so the first one we have here is I have the generic right over Carlos. And what you can do with that is, of course, we can try to reset Carlos's password. That is not very stealthy. We can basically overwrite a lot of attributes on Carlos's user. One nice technique is something called shadow credentials. And it's a specific attribute you can put on computer objects and user objects if you can write to it, if you have permission to write to it. And it's basically you're writing a certificate into that attribute such that when I present the certificate, the domain controller can see, okay, this is written in Carlos's attribute, so this must be Carlos. So let's take a look at that. I'll just bring this one up. So what we can do is Certify has a command called shadow. Maybe I should show you all the commands Certify has. It has some different ones, and each one of them can have more subcommands. we'll use the one called shadow, and it says abuse shadow credentials for account takeover. So we want to take over your account. And again, we can list the help for shadow. As you can see, there are a lot of options. We will start by adding a shadow credential. So first we'll specify our own user and our password. And then we will set the account, which is our target. We'll set it to Carlos. Let's see if it works. Okay. So let me zoom out a bit. It will print out a lot of stuff. It will say it's generating a key credential, which is basically this shadow credential. Shadow credential just sounds more cool, more attacker-like. And then it prints out a device ID, but most importantly, it saves a certificate and a private key for Carlos. So this certificate is written into your attribute, your Carlos attribute, and now we have the certificate and the private key. So the next step.
Okay. Oliver, I need to stop you for a second right there. You are going to
Yep.
hate me at this point in time. I need us to restart the Zoom call because we are going to be kick off because I didn't pay. So
Okay.
if you can just connect to the same call, or I will be waiting for you there. Okay.
Okay, cool.
Okay.
I don't know how to close it.
Don't worry. Okay, so we are just getting the connection back in a second. Okay, so for the moment we have abused some attribute writing privilege over the Carlos account to write a new certificate that I guess Oliver now is going to be using to compromise my account. Thank you for that, Oliver.
You're welcome. Can you hear me and see me?
Yeah, all good.
Great. Okay, so yeah, I didn't do anything since last time. So we're still here. We just got the certificate for Carlos. This one is written into Carlos's attribute, key credential. And now we will authenticate with the certificate, and Certify has a command called auth for authenticate. And then we specify the privesc, which is the file that was just saved. You should be able to see it saved here locally. So we will do that. Carlos.privesc. And now, if we just try to run this command, you will see Certify complaining because there's no identification inside the certificate. Certify doesn't know the username or the domain. Why should it even contact? Because it's just an empty certificate. So we can, of course, specify that. We can say the user is Carlos and the domain is hacktricks.live. Didn't work. Let's see, could match debug. Probably I should say domain. Okay. It will connect to the domain controller and use the certificate for logging in, for getting something called a Kerberos ticket, which is a proof of identification. It can take some time, but basically we're using the certificate, we're presenting it to the domain controller. We're saying, can you log us in? The nice thing about Kerberos is when you have a certificate and you want to authenticate, well, maybe not all protocols, all servers in your environment supports certificate authentication. So there's a cool feature saying, hey, when you're logging in to the domain controller, hey, can I also get my password hash? And you can get that. And of course, Certify wants to abuse that. So here we just got the NTLM hash for Carlos. That is very cool. For those viewers who might not be familiar with NTLM hashes and Windows environments, there's an attack called pass the hash, which for most protocols, instead of having the password, it is sufficient to just have the hash of the password, because the password for most protocols are hashed before it's sent to the server. Okay, so now we have the password hash for Carlos, so we can pretend to be Carlos. So on to the next step. Carlos has write account restrictions and all extended rights over Carlos PC. So we can do different stuff on Carlos PC, which is basically just another user. In this case, there's not even a PC, there's no server. It's just an object saying there is a computer. So it's similar to a user, except it has some different memberships, has a different account name, it has some different attributes and so on. But we will just pretend it's just a regular user, and Carlos can reset its password, for instance. And Certify has some commands to manipulate user and computer objects. And this is mainly because of the vulnerability I will show you later on. So it has a command called accounts. And what you can do is you can create, read, update, and delete accounts. So in this case, you want to use the update command to manipulate colors. And then it says we should specify user. So the user is Carlos PC. And again, since this is a computer object, it should end with $. That's not always the case, but for most default computer accounts, it ends with $, even though you cannot see it. Perhaps it says here, yeah, the SAM account name, Carlos PC $. The SAM account name is more or less the logon name. Okay, cool. And we should also remember to specify our user, which is now Carlos, that we compromised. And instead of specifying the password, we can specify the hash that we just got, the password hash, that one. Let's see if it will work. Maybe we should start by just reading the user. Okay, so we can now see that the credentials did work. We can see a bit, just some small things about Carlos. What is his ID and so on. But what we want to do is we really want to update the password of Carlos PC. So let's make a secure password again. Sorry, wrong one. It should be update. No, certify account. Do I have? Oh, I have too many commands. Yeah.
Yeah, looks like it.
What? Okay. I don't know. Okay. I understand what happened. I didn't quote the double. So let's just. Something is not working properly. Okay, we should do it like this.
You put 2 single quotes at the end.
Thank you. Okay. Thank you. Okay, so this looks a bit right. Certify account update. We are want to update Carlos PC.
Can you make the screen a little bit bigger?
Yeah, we can try. Looks a bit funky now.
Yeah, sorry.
Is it better?
Yeah, definitely.
Okay. So yeah, account update Carlos PC. We are the user Carlos because we compromised you with the hash, and now we want to update the password, which should be pass. And it's updating user Carlos PC, successfully updated Carlos PC. Okay, so until now, we didn't really touch the certificate template. I just wanted to show you the power of Bloodhound and how we can compromise our way onto the certificate template. Okay, so now we have the credentials, we have the password of Carlos PC, which is a member of the main computers, which can then enroll into the server template. Okay, so let's try to just request the template. So the command for that is rec. You will see some different stuff, a lot of different parameters you can specify. We will only touch a few of them, but there are a lot of different parameters in case your environment is different. Maybe you want to specify some IPs instead of host names and so on. Okay, so first of all, our username is now Carlos PC at actrix.live. Our password is password. And then we should specify the CA, which is, let's take a look at the template. It says that certificate authorities is lab root CA. So that is the name of our CA. It's not the server name, but the name of the certificate authority. And then we specify as a target, we specified the server DNS name. Okay. And the final thing we have to do is specify that the template we want to enroll in is called server. So if everything works, let's see, connecting. Sometimes I see this is timing out. Yeah, just need to run it again. Only in my environment. In the real world, it's fine. There's something wrong with my, I don't know what is wrong with my environment. But in this case, we got the certificate. It says successfully requested certificate. It also prints a request ID. So our request was number 31 in this environment. And it also says got certificate without identification. So if we wanted to use this certificate. Let's just try it out. And let's just specify the user is Carlos PC, and the domain is hacktricks.live. If we try to, yeah, get that. If we try to authenticate, it will say name mismatch between certificate and user. And this, I have seen a lot of issues on GitHub for Certify. Why do I get this error? And it's basically because the certificate doesn't match the user we try to log in with. And there's no identification in the certificate. But we know this one is vulnerable to ESC01 technique, and that is what we will exploit right now. So let's get back to the request command. Now, since it's vulnerable to ESC1, what we can do is we can specify an arbitrary username, which is marked by the -UPN flag. So we can say administrator at hacktricks.live. So we are asking the certificate server, please issue the certificate with this username inside it. And the reason we can do that is because it has the enrollee supplies subject attribute. That means we, as the enrollee, as the user, can supply our own subject. So if we try to run it, let's hope. Time out again. Just needs a few tries. Now it says, got a certificate with the UPN, administrator at hacktricks.live. Okay, it saved the certificate. Let's try to authenticate with the certificate. But this time, since we have some identification inside the certificate, what Certify will do is it will try to extract it and then guess where it should authenticate and with what user. So we don't have to specify the user and domain anymore. So let's try to authenticate. And we got the NTLM hash for the administrator.
Awesome.
So this might seem like, okay, what can we do with that? But let's just try to authenticate with Win Remote, for instance. Let's see if I can remember the syntax. Probably DC. Okay. So here again, we are using pass the hash attack. So we don't need to know the password. We just need to give the password hash. And now we can see we are Hacktricks administrator, and we are logged into the domain controller. Okay, so it was just to demonstrate that we do actually get the domain administrator's credentials.
Yep, definitely.
Okay,
definitely.
so that was ESC1. It can come in different varieties. Maybe it's not domain computers, maybe it's just domain users instead. And hopefully I can show you how that vulnerability can happen, how easy it is to introduce the vulnerability in your environment, just so you, the viewers, might get an idea of how can this even happen. How can someone specify the enrollee supply subject?
Sounds good.
This misconfiguration is the one we see at our pen test the most, because some environments are really old, and back then maybe they didn't know about all these vulnerabilities, but the templates are still there. It's still configured this way. So this is what it looks like from the administrator interface.
Is there any way you can make that bigger?
Tough question. Let me see. Any display. Yeah, I only gave it maybe one CPU. Maybe I can.
Windows didn't have some kind of magnifying glass that you could use.
Oh, maybe it does. Magnifier. Oh.
Okay, that
can
worked.
you see it? Okay. I have no idea how I exit this one. Okay. How do I? Okay. Yeah. Okay. It's a bit difficult, but this is what the certificate authority will look like to a system administrator. We have the labroot CA. We can see some revoked certificates, issued certificates. So here we can see all the certificates that have been issued. A lot of my testing, but most recently we have like Hacktricks for Carlos PC. And here are all the certificates that templates that are enabled. So the way you create certificate templates is you click manage. And the only way to, as far as I know, to create a new certificate template, is by duplicating an existing one. So Active Directory certificate services will come with some default ones. Not all of them are installed. But for instance, this one called web server, it is enabled by default. And perhaps as a system administrator, you think, okay, the web server template is almost what I need. I'll just duplicate this one. And then you will get all these fields. Most importantly, the subject name. This little checkbox is what can compromise your entire domain. Supplying requests, which makes the user being the enrollee can supply the subject inside the request, and the subject is the username in this case that we did before. Or it can be built from Active Directory information. So if that one was checked and we try to request it, it will just put our username inside it. We couldn't specify it ourselves.
Okay.
So let's pretend we are system administrator. We just get this one. We duplicate it. We say our server authentication. No, I also want to use it for client authentication. Okay. And security. Perhaps I want also users to enroll in it. Okay, now you're vulnerable. So it's really just a few clicks. And as a system administrator, when you're setting this up, probably you don't want to understand all of it. You just want it to work, because certificates are really difficult to get right, especially if you don't have the knowledge about them, like deep technical. So you click checkboxes until everything works, leave it alone. And that is how you become vulnerable. So that was just to show for ESC1 why we see it so often. It's because templates are duplicated. Maybe some checkboxes are already there. You add some new permissions and new attributes.